Hi, welcome to Chemistry Made Easy. Today we are going to look at part 3 of radioactivity. In this part, we are going to look at the calculations involving radioactivity. So let's get into the topic. In today's lesson, we are going to look at calculations involving radioactivity. So we are going to look at how to calculate for radioactivity using both mathematical method and the graphical method. We are going to take some examples and then we'll see how we go about it. So let's look at the formulas. In the mathematical method, we will be making use of the following formulas. The half-life of our radioactive element is equal to 0.693 on K, where K stands for our decay constant. We also have KT, where T is time, is equal to the in of our initial amount all over final amount. Or we can use KT is equal to 2.303 log into bracket the initial amount all over final amount. And for the graphical method, we'll be looking at the final amount being equal to our initial amount divided by 2. So we are going to take some examples and see how we apply these formulas in solving questions. So let's start with the mathematical method. Example. The decay rate measured by a gigamolar counter for a radioactive sodium-24 at different times are, so I have activity or count, which is a unit. Then we have time in hours. So we have 200 on 0, 100 on 12.2, 50 on 24.4, 25 on 36.6, 12.5 on 48.8. So we were asked to find the half-life of the sodium-24. So find the half-life of sodium-24. We are going to solve this example using the two methods, graphical method and the mathematical method. Let's start with the mathematical method. So, solution. So to calculate for my half-life, 0.693 on K, but I don't know K, so I am going to apply the next formula. KT is equal to my N into bracket N0 on N. So I don't know K, but I know T. We were given the individual times in the data provided. So we are going to choose our initial amount and final amount, and we take their corresponding time. Then when we find their change in time, it gives us T. Okay, so if I am to use N0, let's say 200, its corresponding T1 would be 0. So if I take N, which is my final amount, let's say I'm using 12.25, its corresponding time would be 48.8. So my change in time would be T2 minus T1. So I'm going to get 48.8 minus 0, which will give me 48.8. I'm going to substitute this data into this formula. So I'm going to get 48.8 times K will give me 48.8 K. I'm going to have into brackets my 200 divided by my 12.5. I'm going to get 48.8 K is equal to into bracket 200 divided by 12.5 using your calculators. If you do that properly, you should get 2.7726. So I'll divide here by 48.8. Here by 48.8. This will cancel. K would be equal to 0.05682. That gives me the value of K. Now I can go ahead and calculate for my half-life. So my half-life can now be 0.693 on K. Now 0.693, my K is 0.05682. When I use my calculator, you should get 12.2 hours. That becomes the half-life of sodium-24 with the following data. So you can use any of the activity with their corresponding times and you should get the same answers. So that is how we use the mathematical method in calculation involving radioactivity. Now, let's take the same example and then see how we can use the graphical method in solving for the half-life of sodium-24. So we're going to plot a graph. So on your x-axis is your time. Its corresponding unit is hours. On your y-axis, we have activity, count. So I have 0. So I will start from the least to the top. So let's say every 2 centimeters, 12.5, 25, 50, 100, 200. The time also starts from 0. I have 12.2, 24.4, 36.6, 48.8. Now I'll look for, now the first one is 0 on 200. So 0, I trace to 200, I plot my point. 12.2 to 100, I trace to that, I plot my point. 24 and 50, I trace, plot my point. 36.6 to 25, trace, plot my point. Then 48.8 to 12. I plot my point. So when you are done, you join your points together. So after joining this point, now we have to calculate for our final amount using the formula final amount is equal to our initial amount on 2. So here my final amount, I'm going to use the highest count, which is 200. I divide by 2. So I have n to be equal to 100. That becomes my final amount. So I'm going to trace, go to the count, look for 100, then trace to its corresponding time. So it means that the half-life of my sodium-24 is 12.2 hours. So that is how we can use the graphical method also in finding the half-life of a particular radioactive nuclei. Now let's take another example. So example 2, a radioactive element decays from 256 gram to 32 gram in 15 hours. A. Calculate the half-life of the element. B. Find the time it will take for the element for the sample to reduce to 8 gram. So this is our example 2. Let's see how we solve that. So solution. So with this type of question, we cannot use a graphical method, only the mathematical method. So I know that my half-life is equal to 0.693 on K, but I don't know K. So, but I also know that my KT is equal to my N into bracket N naught on N. So with the information I have, I know N naught. They say the initial amount is 256 gram. My final amount is 32 gram. The time is 15 hours. So with this data, I can find my K. So 15 times K will give me 15K. N into bracket 256 over 32. So I'm going to get 15K is equal to, using your calculators, N into bracket 256 divided by 32. If you do that well, you should get 2.0794. So we make K the subject. So I have K to be equal to 2.0794 divided by 15. And I should get K to be equal to 0.1386. So now that I know K, I can find the half-life, which is my half-life will be equal to 0.693 on K, 0.693 over 0.1386. So the half-life will be equal to 5 hours. That answers question 1. Now let's go to the next question. It said find the time it would take for the sample to reduce to 8 gram. So we are finding time. So I don't know T, but I know K now. This is K. So I have, using this formula, KT is equal to my N into bracket N naught on N. I have 0.1386 times T will give me 0.1386 T. So N into bracket my 256. This time my final amount is not the 32, but it's 8 gram. So I have 8. So I have 0.1386 T is equal to, so when you use your calculators for N of 256 over 8, you should get 3.4657. So T will be equal to 3.4657 divided by 0.1386. So T will be equal to 25.0 hours. So that is how we can calculate for the various questions using these formulas. Okay. Now let's try another example, which is example 3, and see. Example 3. A radioactive substance. A radioactive substance. So example 3, a radioactive substance has an initial mass of 160 grams. After 12 hours, the mass reduces to 20 grams. A. Calculate the half-life of the substance. B. Determine B. Determine the mass remaining after 18 hours. So this is the third question. Let's see how we go about it. So to calculate for half-life, so solution. I know that half-life is equal to 0.693 on K. So I don't know K. But I know that KT is equal to my in into bracket N naught on N. So I will first of all find K using this formula. So I have my time here is 12 hours. So 12 times K, I'll get 12K is equal to in into bracket. The initial time or initial mass, sorry, is 160 grams. Then the final is 20. So I'm going to get 12K is equal to my in 160 on 20. You should get 2.0794. So when I divide here by 12, this place by 12, I'll have K to be equal to 0.173. Now that I know K, I can find my half-life, which is equal to 0.693 on K. So 0.693 on K is 0.173. So when you divide that, your half-life would be equal to 4.0 hours. So that answers question 1. Now let's look at the next question. Now we should determine the mass remaining after 18 hours. So we are looking for the final mass. Okay, so now I know K, I know T, which is 18 hours. I know the initial amount, which is 160. So we just find N. Okay, so I have KT to be equal to my in into bracket N naught on N. My K here is 0.173. My time here is 18 hours. N into bracket 160 over N. When I multiply this by that, if you do that properly, you should get 3.114 in. So I get in into bracket 160 on N. I'll divide here by in, divide here by in. So the in cancels. So I'll find the in inverse of this value. So finding n inverse gives me 22.51, which is 160 over n. I multiply here by n, this side by n, this cancels. So my n will be equal to 160 divided by 2251. So n will be 7.11 gram. So that means that the mass that will remain after 18 hours is 7.11 gram. So this is how we calculate for, this is how we do calculations involving radioactivity. I hope you understood the lesson. If you did, I urge you to subscribe, share, like, and comment.